Hi there, exercise 4A.2. We're very particularly going to look at the square root of a complex number, it's quite a useful technique. Comes up on the exams loads. It's not particularly in the textbook as far as I remember, but that's why I've separated it out and given you a separate lesson on this, because it is important. A little starter for us first of all. We want to be able to use this Casio class Wiz to be able to go into and do complex numbers on there. So one of the things I want to show you is first of all how to do it. So press the mode button, that's this one here, press 2, which comes up complex, and when you do that I want you to do a little sum. See if you can type this in for me. Now I want you to type in the first complex number is 3 plus 2i, and I want you to add to it minus 2 plus I. Now it's something you could do easily yourself. I'm not saying this is hard. But this is where, by the way, you find the I. It's written in purple just there. There's I. So when you're typing this in, 3 plus 2i plus negative 2, you might want to use this negative 2 here, or I suppose you could just say plus and minus is a minus, that would work as well. But plus a minus 2 plus I again. And see what you get as an answer. It should obviously come up with 1 plus 3i, because that's what you'd get if you did it. Obviously 3 take away 2 is 1, 2i plus I is 3i, so that should be the answer you get. So I'm just trying to make sure you can know how to use your calculator properly. One problem though is I've started off by saying I want to square root the complex numbers, and so unfortunately you can't actually get your calculator to do it. Type in for me this, I've written here the square root, I'm not sure if you'll be able to see it all the way down there, 3 minus 4i. Tell your calculator to do that. I've not sussed how to do that on this calculator. I think on the big black one you might be able to do it, but on this one I haven't managed to do it, because on this one it gives me a maths error. I don't think it likes the having to try to square root all these i's. And of course remember what I is. I is the square root of minus 1. So it's to a certain extent it's not surprising it gets a bit confused, poor little thing. Square root of 3 minus 4 times by the square root of minus 1 is kind of square root within a square root. So for this reason, if we want to find the square root of a complex number like this one here, so with our calculator not being able to find the square roots of the complex number, actually I think the black calculator can, but we therefore need a method for doing this, and this is would be described as, I suppose, an algebraic method for doing this. So I want to run through the method with you now. So we want to find the square root, so let's just go for it. The square root of 3 minus 4i. Now look, we have to assume that it's a complex number. That's the first step. The complex number I'm going to write as a plus bi. Could use any letters, I'll be using a and b. So that's our first statement, but just I also need just to make you aware that a and b are real. And by real I mean they're not complex numbers within a complex number. So if I'm writing this as a complex number, my assumption this is a 2, this is a 5, this is a minus 10, this is a 1. You know what I mean? They're proper numbers. So but with that assumption made, I don't like the fact that it's a square root because we can't do it. So let's move it on to the other side. And when you move a square root over, it becomes a squared. So it's a plus bi squared. So let's multiply out that bracket. It's obviously a plus bi times by a plus bi. And if I do that, I get a squared plus 2abi. Could you do it twice? But the last one's a bit weird. Look at this. It's b squared I squared. Now I squared should remind you of something we've seen last time. I squared is the same as minus 1. And that matters because we can now get rid of that I squared and make it a negative. So this is really a squared plus 2abi minus b squared, and then there the I squared's gone. Don't forget what this is. This is now 3 minus 4i. And what we can do is we can equate the real and imaginary parts. So I'm going to write the possible name for this, what we're about to do. We're going to equate real and imaginary parts, which basically means we look at the left hand side and say how many real numbers are there, and we look at the right hand side and how many real numbers are there, and we say they're the same. So by that, let's do the real ones. You usually write this RE because we're too lazy in maths. And you look at the left hand side, there's 3. 3 is the real number. Hasn't got an I on it. And on the right hand side, your a squared hasn't got an I on it, and the b squared hasn't either. A squared minus b squared. That gives me one equation. I do the same thing with the imaginary parts. Again, a bit lazy. Imaginary written IM. On the left hand side, the imaginary part, the bit with an I, is just minus 4. Notice I don't write the I. I just say how many i's there are. It's minus 4 of them. On the right hand side, it's 2ab. And these are basically simultaneous equations, which I'm now going to try and solve. And the one you always play around with is this one. It's not like the ones with, simultaneous equations you saw at GCSE. A bit more work here to do. We use the method of substitution. So I move everything over. Let's see if I can get a on its own. So if I move the 2 over, and I move the b on the bottom as well, I reckon the minus 4 divided by 2 is minus 2 divided by b. And since my top equation says a squared, I'm going to do a square of that, and minus 2 times minus 2 is 4 over b squared. So I now substitute this in to this equation. So it says 3 equals a squared. Don't like a squared, I'm going to write 4 over b squared, and it says minus b squared. Now I'm not sure about you, I think that actually is starting to look like a disguised quadratic equation. So if I times everything by b squared, I reckon this gives me 3b squared on the left equals 4 minus b to the 4. Yes, it is. Move the b to the 4 over, move the 4 over, because the quadratic equations, we always like having them equal to 0. Now, I'm going to factorize this. I'm going to put b squared. Now, you could factorize this. We did a method in the normal maths where we wrote y equals the middle term. You could do that if you want. But I'm just going to jump straight in for it. It's b squared, and that's going to be at the front of both of them. And I reckon it's plus 4 minus 1, because I want to end up with plus 3b squared in the middle. And therefore b squared is either minus 4 or b squared is 1. Now this is actually a bit of a problem for us. Remember what I said, a and b are both real, they're proper numbers. Now if I try to square root minus 4, it doesn't give me a real solution. This is no real solutions. So although it's potentially an answer, in actual fact it's not. This is though. I can square root 1, b equals plus or minus 1. We've got it. Well, not quite, I've still got to find a. Do you remember a was equal to this? So I could write a is minus 2. Now there's two answers here. Perhaps it's better if I write plus 1 or minus 1. Now when b is plus 1, a is minus 2 divided by 1, which is minus 2. But when b is minus 1, a is minus 2 divided by minus 1, which is plus 2. Well, bearing that in mind then, we initially said the square root of this, square root of 3 minus 4i, we said it was equal to a plus bi. What's my a? That's minus 2 plus I. Notice how the negative one goes with the positive one. Or it could also be 2 minus I, because again the positive one is with the negative one. So I've got two answers. I've got two answers to a square root problem. Well, there you go. This is the posh answer, which I wrote out a couple of years ago, but I've just shown you the full working. Look, I've got answers here at the bottom. I don't know why I've got answers at the bottom, but there you go, I have. Now this then, we're going to try to do the same thing, solve this equation. So very first thing I notice, it says z squared equals this. So z is clearly the square root of minus 21 minus 20i. On the face of it, that's easy, but of course we've just spotted the root. Doing this isn't easy at all. So I'm going to say this is equal to a plus bi, and I make the same assumption every time. A and b are real numbers. So let's go through this process, and hopefully I'm going to end up with these answers at the bottom. Move the square root onto the other side. That gives me minus 21 minus 20i equals a plus bi squared. Now this actually becomes the same thing every time. It will always be a squared plus 2abi minus b squared. And because of that, when we do our real and imaginary parts trick, you could almost jump straight to it. The real parts are that minus 21 equals a squared minus b squared. The imaginary parts, basically say I've got minus 20i, so I'm going to write minus 20 equals this 2ab, because I've got 2abi. Notice I don't write the i's. I solve these simultaneously by rearranging this to get a equals. A equals, well, 2 divided into that minus 20 gives me minus 10 over b. I think last time I wrote a squared immediately, which is 100 over b squared. You'll notice these methods are basically identical every time. What now? Well, now I have to sub that into this first equation. Therefore, minus 21 equals 100 over b squared. That's the a squared minus b squared. I think I times everything by b squared, which gave me minus 21b squared equals 100 minus b to the 4. I think I'm going to move it all over to the left again. B to the 4 minus 21b squared minus 100 equals 0. Not so obvious as to what the answers are here, so I'm tempted to type this into my quadratic equation solver, because really it is a quadratic equation. So menu, I need to go down to A. There's a polynomial of degree 2. Don't be confused. It is a polynomial of degree 2. At least we're pretending it is. And when I type in 1x squared and negative 21x and negative 100, it gives me two answers, which are 25. So here I'm going to write b squared. It says 25, so I'm going to write minus 25. And my second answer, it says, is minus 4. So I'm going to write b squared plus 4. And I'll just do that to make it look as if I've done it properly, even if I've cheated. And now I can write b squared equals 25. Or b squared equals negative 4. Now this one, no real solutions. We can't square root a negative. But this one we can. b equals 5 or minus 5. So that's good because I've got 5s in here. So a then, what was a? There was a formula for a somewhere, it's there. A equals, when it's 5, it's minus 10 over 5, which is minus 2. Or if it's minus 5, it would be plus 2. So I think I can quite happily now write the square root of minus 21 minus 20i. And I'm going to be a bit lazy here. I'm going to write the a's first. What is it? It's either plus or minus. So it's plus or minus 2. Now notice how, again, it goes from minus to plus, plus to minus. So you show that with a minus plus, which means it's the opposite way round, 5i. So if I was being lazy, that's how I'd write it. But there's no problem in writing both of them out like that. In many ways, it's better. Now, in class, I think I've got a few of these to do, so we'll practice these a bit more. And there's no problem with doing that in class. There's 4 I want to practice, and there's an exam question I want to show you. There's the answer, but we'll worry about that later. Now, one thing I would show you, some of you will be thinking you want to go to Oxford or Cambridge. Now, this was some former Cambridge University entrance exam questions, and some of them will be possibly something you could do now. Some of them perhaps you might not be able to, but I just noted this. It says find the square root of I, and this, remember, is non-calculator paper. They were just saying, do you know what the square root of I is? Could you do it? Interesting. I think one of the questions I put up here a couple of questions ago, eventually I'll get there. Oh, it wasn't I, it was minus 2i. But let's find the square root of I was one question. Now, this question, oh, I lost it. Lost my pen. This question here, we haven't yet done this, so don't be surprised. This is actually called mod x, but we haven't done that yet. The question 3 might be quite doable as well, but I'll leave you to have a think of it. Anyone who's thinking of possibly applying for Oxford or Cambridge or one of the other elite universities like Durham or Warwick, very good university for maths, or some of the London ones like LSE or King's or something like this. So anyway, all the best, and I hope that makes sense.